cool chemistry cats, it's Miss DeAngelis here. I wanted to go over the assignment that you have today just to make sure that we don't have any misunderstandings. Okay, so one of the first things we're going to do is you are going to open up your assignment from Schoology in your folder. Make sure you're checking the date with the dates on the folder so that you can't say, Miss DeAngelis, I don't see the assignment. So, and by the way, guys, if you don't see the assignment, please check Google Classroom because a copy will be there if for some reason you can't get into your Schoology assignment. The first thing you're going to do is you are going to open it up and you are going to look at your interactive periodic table in your folder to complete the assignment. I want you to use a different color to show your work. Obviously, this is typed in black, and having a different color is eye-catching for me, and it's easier for me to grade. So if you want your grades sooner than later, please just put your responses in a different color. We are going to do an example together, and I want you to submit your work on Schoology. Please don't submit it on Google Classroom or email it to me unless you have prior approval, because it's hard for me to kind of figure out where all your stuff is. So let's go ahead and review some of the concepts in the periodic table first. So let's talk about groups and periods. Let's start with groups. We know that groups relate to the number of valence electrons, which are the electrons in the outermost shell, for an element. So if I were to highlight group 1, it's telling me that all of the elements that are in this column have 1 valence electron in its outermost shell. I'm going to highlight group 2. These are the ones in the outermost shell, have 2 valence electrons. Now, if I click on 3, it's going to take me here, which are your subatomic S, P, D, and F. So I actually want you to bypass the groups right here from 3 to 12, and I want you to focus on 13, 14, 15, 16, 17, and 18. If we actually cross off the 1 in front of this 13, we'd get 3. And again, cross off the 1 in front of 14, we get 4, and so on. It's 5, 6, 7, and 8. If I cross off this 1, I'm left with 3. It's telling me that I have 3 valence electrons in the outermost ring for all the elements that are in this column. So again, guys, don't focus on the ones over here. These are subatomic. These are ones you're not even going to really deal with. You'll see these guys in AP Chemistry. We can do some of that for those of you that are dying to learn AP Chemistry, but I'm not going to do it here in this video. So again, let's click on 14. This means that all of the elements in this column have 4 valence electrons and so on. And remember, all the guys that are in column number 18, which is really 8 valence electrons, means that the outermost energy ring is completely full, and they are not reactive with any other element on the periodic table simply because they cannot house any more electrons, accept any more electrons, and they're pretty much going to stay in their full state. So guys, consider like helium. Pure helium goes into a balloon, which helps it to inflate. Okay, so if we were to do our example together, let's start with lithium. If I go back to my periodic table and I'm looking for the atomic number, let's see, lithium's right here. So my atomic number is going to be this number at the very top. So my atomic number is 3. I'm going to go back. I'm going to choose purple because I love purple. And I'm going to say it's 3. My atomic mass, going back, it's this number that's at the bottom. 6.941 is really close to 7. So I'm going to say that it has an atomic mass of 7. That in. Protons, I know protons are equivalent to the atomic number. So that's pretty easy. So I'm going to say it's 3. Neutrons, you need to subtract the atomic number from the atomic mass. And that's because the atomic mass is made up of the protons and the neutrons. So that's like saying I have 7 cookies. I know 3 of them are Oreos. How many are chocolate chip? The answer would be 4. So my neutrons are 4. So if we put that in another word problem, it's like saying, I know that I have 7 protons and neutrons. I know 3 of them are proton. How many are neutron? I'm left with 4. So as always, if an element is to be on the periodic table, we know the charge has to be 0. So if I have 3 positive, I have to have 3 negative, and I know the charge for a proton is positive, and I know the charge for an electron is negative. So a negative that has the same amount of positive is going to be 0. So valence electrons, let's go back to our periodic table. I know that valence electrons have to do with groups, so I'm going to select groups. And we know that lithium is in group number 1. So you can see all of these elements are highlighted in group number 1, meaning that we have 1 valence electron. So I'm going to make this purple and say 1. And group number, we know that we just established that is group number 1. And period has to do with the number of energy rings. So I'm going to go back to my periodic table, click on periods. Now, if I simply count down, guys, in 8th grade, we're only dealing with periods 1, 2, and 3. So again, periods 1, periods 2, and period 3. So if I recall, lithium is in period 2, and period tells me the number of electron shells or energy rings. So I have 2 energy rings for lithium. I'm going to demonstrate that in a second. So I'm going to say 2, make this purple. And even though your assignment has the 3 energy levels, I'm just going to demonstrate that we have 2. So remember that each energy level has a different amount of electrons. So the first one has the maximum of 2. So I know that I can put 2 electrons here because I know the first energy level can house at most 2 electron. So level 2, how many do I have left? I know I have a total of 3. I've already put 2 inside my Bohr model. So that means 2 plus what is 3? It means that it's 1. So I'm going to put 1 left over. And level 3 doesn't have any. And in a perfect world, this would only have 2 energy rings. So don't even worry about the third. You actually wouldn't be drawing the third, but for this example, you'll see that all of your models look the same just for simplicity's sake to get for the assignment. But anyway, it has 2 energy rings around that nucleus. So guys, if you have any questions, let me know. Please turn this assignment in on Schoology. Again, don't email it to me or turn it in on Google Classroom because you will not be receiving credit for it unless you have permission from me because you're having some technological difficulties. But again, if you have any questions, let me know. Otherwise, good luck, and I will talk to you guys soon. Bye.